Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, Finite and Infinite Decimals. Opening exercise, use long division to determine the decimal expansion of 54 divided by 20. So, long division, so I'll do it over here. 20, long division, 54. Well, 20 times 2 is 40. Subtract and get 14. Bring down a 0. And 2 goes into 14 7 times. 7 times 2 is 14. 140, no remainder. So the answer is 2.7. Use long division to determine the decimal expansion. 7 divided by 8. 0. 9 times 8 is 72. Too big. I'll go to 8. 64. Subtract. 10 minus 4 is 6. 7 times 8 is 56. Subtract. Get 4. Bring down a 0. 5 times 8 is 40. No remainder. The answer is 0.875. Okay, continuing on. Dividing 8 by 9. Obviously 9's bigger, so I have to put a decimal. It's 0 point something. 9 times 9 is 81, so I'm going to use 8. 72. Subtract and get 80 minus 72 is 8. Look familiar? It's just going to be repeating decimal forever and ever and ever and ever and ever. So the answer is 0.8, repeating the 8. D. 22 divided by 7. That looks familiar. I think that's a fraction approximation of pi. So 22 divided by 7 is 3. 21, subtract, get 10. 7 goes into 10 once. 7, subtract, get 3. 7 times 4 is 28. Subtract, get 20. And it's going to be 7 times 2 is 14. Subtract and get 6. 8 times 7 is 56. Subtract and get 40. 7 times 5 is 35, and it goes on and on and on and on. And 7 goes into 57 times. I'm going to stop there. So it's 3.14287 dot 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 dot, meaning it goes on forever and ever and ever. Okay. E. What do you notice about the decimal expansion parts A, B compared to the decimal expansion parts of C and D? Well, part A stopped or was finite. So was B. So A and B were finite, whereas C and D were infinite. They went on forever and ever and ever. Okay, why was that? Good question. We'll lead into that. So I just said what E is. I'm going to continue. Example 1, consider the fraction 5/8. Write an equivalent form of this fraction with a denominator that is a power of 10, and hence write the decimal expansion of this fraction. This is a really cool lesson, by the way. Okay, so we want the denominator that's a power of 10. Okay, so in other words, we want the denominator to be 10 to some power. So when I take the decimal fraction, or the fraction 5/8, and write it in a decimal expansion, 5 is prime, so the numerator is just going to be 5. 8, if I did a factor tree, is 2 times 4. Try that again. My 4s always snap and look like 9s. 2 times 4, and 4 is 2 times 2. Hence, 2 times 2 times 2 is 8. So 5/8 as a power or decimal expansion is 5 over 2 times 2 times 2, but that is not to the 10th power. Well, I have 2 times 2 is 4 times 2 is 8. 8. I need to find something to multiply to get powers of 10 down below. So what I'm going to do is multiply. Well, 5 times 2 is 10, and I have 3 2s. So what if I multiply 5 times 5 times 5? Okay, this 5 goes with this 2 and makes 10. This 5 goes with this 2 and makes 10. This 5 goes with this 2 and makes 10. And that would be 10 to the 3rd power. But what you do to the denominator, you have to do to the numerator, or else it is not true anymore. Because this is 5 times 5, which is 25, times 5 is 125. 125 divided by 125 is 1. So I'm just doing a scale up here. So this is going to equal 5. Let me change colors again. This is going to equal this 5. Let me do it in the colors I used originally. How about that? So it's going to be 5 times 5 times 5 times 5. Okay, this 5 and these 3 5s make 4 5s divided by, and 2 times 2, so it's going to be, now it's going to be 2 times 2 times 2 times 5 times 5 times 5. Okay, so once I do this, 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625. Let me get this out of the way. Divided by, and 2 times 5 is 10. 2 times 5 is 10, and 2 times 5 is 10, making 10 times 10 times 10, or 10 to the 3rd power. And there is my decimal expansion of the fraction 5/8 as a decimal denominator power of 10. Okay, we're leading up to something here, so you're probably wondering why we're doing this. There is a reason. Number 2, consider the fraction 17 divided by 125. Is it equal to the finite? Is it equal to a finite or an infinite decimal, and how do you know? Okay, good question. Okay, I can rewrite 17. We know that 125 from this problem up here, 5 times 5 is 25 times 5 is 125. So I know that I can rewrite this as 17 over 5 cubed. Okay? So we know that the fraction 17 over 25 is equal to a finite decimal because the denominator is a product of 5s, specifically 5 cubed. And so we can write the fraction as 1 with a denominator that is a power of 10. What will we need to multiply 5 cubed by to obtain a power of 10? Well, we would need to multiply by that same exponent, but I need to multiply 5 times 2 cubed over 2 cubed to get 10 cubed in the denominator. So this is going to equal 17 times 8 over 10 cubed. 8 times 7, 7 times 8 is 56, carry the 5. 8 plus 5 is 13. We get 136 over 10 cubed, which is 1,000. 10 times 10 is 100 times 10 is 1,000. So that is 136 thousandths. Okay, going way back to elementary school, your tenths, hundredths, thousandths positions. So there is the decimal approximation of that. So now let me go back up to this one. This is 625 over 10 cubed. That tells me how many decimal places. 3 decimal places. 10 to the 1, or 10 to the 3rd is 10,000. Or 1,000, I mean. So that's point, or 625 thousandths. Okay. So if I can get a base of 5 or 2, it is finite. That we know now. Okay, now we're doing exercises 1 through 5. It says you may use a calculator, but show your steps for each problem. Consider the fraction 3/8. Write the denominator as a product of 2's and or 5's. Explain why this is rewriting the denominator. Help to find the decimal representation. Well, if I say 3/8 equals 3 over 2 to the third power, because 2 times 2 times 2 is 8, then I can then multiply this by 5 to the third power over 5 to the third power and get 125 times 3, which is 375 over 10 to the third. So that's 0.375, 375 thousandths. Pretty cool stuff. All right. A lot easier than taking 3 and dividing it by 8 the long way. So now it says find the decimal representation of 3/8. Explain your answer and your reasoning. Well, there's your answer and your reasoning right there. I already did it. Okay, 375 over 10 to the third. So I multiplied it, I scaled it up by a factor of 125 to get a denominator base 10 to a power. Number 2. Find the first 4 places of the decimal expansion of the fraction 43 over 64. All right, first thing I'm going to do is look at the denominator, 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And I'm running out of room. 4 is 2 times 2. So that's 1, 2, 3, 4, 5, 6 2's. So I can rewrite this as 43 over 2 to the 6th. Now if I simply multiply by 5 to the 6th over 5 to the 6th power, I get 10 to the 6th power. So I know there's 1, 2, 3, 4, 5, 6 decimal places, and it said to find the first 4. All right. So 5 to the 6th power is 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 625 times 5. Let me do that. 625 times 5. 3,125, and I need to do it one more time. And get 5 times 5 is 25. 10 plus 2 is 12. 5 times 1 plus 1 is 6. 5 times 3 is 15,625. So my first 4 decimal places are 1, 5. That looks like a 6. 1, 5, 6, 2. It says find the first 4 places of the decimal expansion. So it's 1, 5, 6, 2. Oh, I made a blunder. I didn't finish. Okay, so that is not the answer. So Control Z, Control Z. Okay, this is just 5 to the 6th. I did not multiply it by 43. 15, 625 times my 43. Okay, 16, 15. Struggling here. 625. This 15,625, that should still be there. And I want to multiply it by 43. 5 times 3 is 15. 3 times 2 is 6, plus 1 is 7. 6 times 3 is 18. 5 times 3 is 15, plus 1, 3. 0, 0. Carry the 2. 4 times 2 is 8. Times plus 2 is 10. 24 plus 1 is 25. 5 times 4 is 20 plus 2, 22. 4 plus 2 is 6. 5, 7, 8, 1, 6, 6. So the answer is 6, 6, 1, 8. Or did I forget to carry? Yes, I did. 6, 7, 1, 8. 3, 2, and 1 is a 7. 6, 7, 1, 8. Number 3. Find the first 4 places of the decimal expansion of this fraction. So 29 over 125, which is 5 cubed. And then I need to multiply it by a base of 2 to that same power 3. This is going to give me 10 to the third in the denominator, and 29 times 8. Alrighty, 29 times 8. 9 times 8, 72. 8 times 2, 16, plus 7, 232. 3 decimal places, 0.232. It says find the first 4 places of the decimal expansion. Well, the first 4 places would be 0.02320. All right, find the first 4 decimal places of the decimal expansion of the fraction 19 over 34. Before I even begin, I'm just going to write 19 over, and then off to the side here, I'm going to do a factor tree of 34. 34 is 2 times 17. Okay, 17 is prime. So what can I do with that? Okay, I can't say 2 times to the third power, 2 to the first power multiplied by 5. So what I'm going to conclude at this point, since I have a prime factor that is not 2 or 5, then this is going to repeat. So I'm just going to write this for now. And I'm going to take 34, and I'm going to do long division. And let's see, 5, I think. 5 times 4 is 20. 5 times 3 is 15, plus 2 is 17. Subtract 8. No, I don't need to borrow. It's 9, it's 20. Okay, so it's 5, 0.5, and bring down another 0. 34 goes into 200 5 times. 5 times 4 is 20. 5 times 3 is 15, plus 2 is 17. Subtract and get 30. Bring down another 0. 34 goes into 308 times. 8 times 4 is 32. 8 times 3 is 24, plus 3 is 27. 2, 9, 10, 8, 28. Bring down a 0 to 80. And 8 times 4 is 32. And 8 times 3 is 24, plus 3 is 27. Subtract and get 8. It asks for the first 4. I'm done. It's 0.5588. It does repeat and continue, or not repeat it. It's a non-terminating, non-repeating decimal. It goes on forever and ever and ever. It's infinite because it doesn't have a base of 2 or 5. Number 5. Identify the type of decimal expansion for each of the numbers in exercises 1 through 4 as finite or infinite. Explain why the decimal expansion is such. Okay, so A was, or 1 was 0.375. That was finite. Number 2 was 0.232. That was finite. It stopped. Number 4 was infinite. And the reason is finites have 5s and 2s in the denominator. 5s and 2s. Okay, 2s and 5s. And infinites have other numbers besides 2 and 5. And that is why. Example 3. Write the decimal expansion of 7 over 80 to be finite or infinite. Is it finite, or if it is finite, find it. So 7 over, and I'm going to go over here and do a factor tree of 80, 2, 40, 2, 20, 2, 10, 2, 5. So that is 2 to the 4th power times 5. Okay, well I need the same power of both, so this one's a little bit different. I need to multiply. I'm missing 5. But how many 5s am I missing? Well, if this is 5 to the 1 and I need 4, I need another 3. So I'm going to multiply by 5 cubed. 5 times 5 times 5 is 125, so I'm going to get in the numerator 7 times 125 divided by 2 to the 4th, 5 to the 4th, which totals 10 to the 4th. 7 times 5 is 35, carry the 3. 7 times 2 is 14, plus 3 is 17, carry the 1. 7 times 1 is 7, plus 1 is 8. 4 decimal places, so it's 0.875. 0.0875, because 80 will not go into 7, you add a 0, 80 will not go into 7D, so you have to add another 0. Finally, 80 will go into 700 8 times. Okay, so be careful. The this power right here tells you how many decimal places you're going to end up with. 1, 2, 3, 4. That's your decimal place. Okay, so this is finite, and I found it. Example 4. Okay, write the decimal expansion of 3 over 160. Is it finite or infinite? And if it's finite, find it. So the first thing I'm going to do is a factor tree of 160. 2 times 80. 240. 220. 210. 5. All I have are 2's and 5, so I'm already going to say it is finite, so I need to find it. I have 1, 2, 3, 4, 5 2's, so it's 3 over 2 to the 5th times 5. I now need to get this to have a base of, or a denominator with a base 10. So that would be 2 times 5 is 10, but I need to multiply it by 5 to the 4th. Remember, this is 5 to the 1. 4 plus 1 is 5, so I need to multiply by 5 to the 4th power in the numerator. This will give me 10 to the 4th power in the denominator. I know my answer is 0.1234. 5 to the 4th is 5 times 5 is 25, times 5 is 125, times 5 is 625, so it's 3 times 625. 5 times 3 is 15, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 6 is 18. Booyah. Whoops, I said booyah too soon. See this 5 and this 1? This is 4 plus 1. That's not 10 to the 4th. Everything is correct except that's 10 to the 5th. 5 to the 1 times 5 to the 4th is 5 to the 5th times 2 to the 5th, which is 10 to the 5th. So all I need to do is move my decimal one place. Okay, my apologies for that. There's a 0 here, and then this is my answer. 1, 2, 3, 4, 5 decimal places. Now I can say booyah. Number 6. Through 8 says you may use a calculator, but show your steps for each problem. These are exercises. Pause the video, see if you can do them. Then unpause the video and check your answers. Here we go. Convert the fraction 37 over 40 to a decimal. So the first thing I'm going to do is 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. I have 2 to the 3rd and a 5. So it's 37 over 2 to the 3rd times 5 to the 1. I'm going to multiply by 5 squared to get 3 5s. 5 squared. And that equals 25. So 37 times 25 . 925 if I did my math right. Let me check it. Hey Siri, what's 37 times 125?
37 times 125 is 4,625.
No, it's not 125. Hey Siri, what's 37 times 25?
37 times 25 is 925.
Okay, that's correct. So I only needed 5 squared to get us 5 to the third with this 2 to the third. So that is 2 or 10 to the third. So that tells me that there are 3 decimal places in my answer, and it's 925. Okay. Okay, so this says write the denominator as a product of 2's and or 5's, which we did. Explain why this way of rewriting the denominator helps to find the decimal representation. Well, it tells you how many decimals you need, and it tells you the number when multiplied that you get. If you had divided by 40, you'd get this same number. B says find the decimal representation of 37 over 40. Explain why your answer is reasonable. Well, 37 over 40, we found it. Here it is. There it is. I found it. 37 over 40 is really close to 40 over 40, which is 1. 0.925 is pretty close to 1. It's 92.5% if you're thinking of percent. It's very close to 1, so that's why I think my answer is reasonable. Number 7, convert this to decimals. 250 times 2 or divided by 2 is 125. 125 divided by 5 is 25. 25 divided by 5 is 5. So my factor denominator is now going to be 2 times 5 cubed. Well, I need a 2 cubed. I only have a 2 to the 1. So I'm going to multiply by 2 squared, because 2 squared times 2 is 2 to the third. And that'll give me 2 to the third times 5 to the third, which is 10 to the third. And that's my goal, to get a base of 10 to a power. But if I multiply the bottom by 2 squared, I have to multiply the top by 2 squared. So 2 squared is 4. So the answer is 8. With 3 decimal places would be 0.008. 3 decimal places. Okay. Whoops. Made another mistake. Right here. Wow. 3 times 2 squared is 3 times 4 is 12, which is 0.012. There, that's better. Try not to make a mistake on this one. 1250 divided by 2, 625. Divided by 5, 1, 2, 5. Divided by 5, 25. Divided by 5, 5. So I have 5 to the 4th times 2. So this is 7 over 2 times 5 to the 4th power. I need the 5 to the 4th and the base 2 to be also to the 4th, but it's only 1, so I have to multiply by 2 to the 3rd over 2 to the 3rd. When I do that, I get 7 times 2 is 4 times 2 is 8 over 2 to the 3rd, 2 to the 4th, 2 to the 4th, 2 to the 1st times 2 to the 3rd is 2 to the 4th times 5 to the 4th, which equals 56 over 2, over 10 to the 4th. So my answer is 0.123. 4 decimal places. I only have a 56, so it's got to go back here with 2 zeros. And there we have it. Okay, that is the end of lesson 6. Review the lesson summary and go do your problem set.